Today we're in Crewe. We're installing a commercial solar PV system across 5 different units. The landlord wanted to future-proof the properties and ensure that the tenants really wanted to be in these units for a longer period of time, but also to enhance the energy efficiency of the units. Let's take you around the site and we'll show you some of the key kit and features. Each system is 17.2 kilowatts peak. There's 5 units, 42 panels, 12 kilowatt inverter in each of the units. This unit that we're on is a split system, so half the circuit's facing one orientation, the other half's facing another orientation. So there are 2 separate voltage and PPT power point trackers that both these circuits go into, so they essentially work independent of one another, and they're wired into 2 individual brains so they can cope with the 2 different voltage inputs at different times of the day. This is what's known as a witch's hat. This is a way of waterproofing a hole on the roof. So at this point in the job, we're bringing through DC cables that run from the inverter up to the solar array on the roof area. And the witch's hat has a rubber seal around the edge, so a rubber gasket. We've also put in some high-grade sealant around the edge as well, just in case. And then we've basically screwed all the way around the perimeter of that, compress it down, the gland thins out, and creates a seal around the edge. And then as just good measure, we've also fitted some sealant around the edge. But this is fully waterproof, and even the cable entry point where the cables come through, they're raised up off the roof as well. So you're kind of designing any potential failure point out of water ingress getting in. We're about to start running the DC cables from the roof. So far we've wired from the DC isolation switch into the bottom there. We've labelled up there string 1. String 2, and we've labelled up with heat shrink on there, string 1 pos and string 1 neg, and string 2 pos and string 2 neg. And you'll see here, if I take the enclosure lid off, we've identified the cables, and we put the slack inside of here. It's just a bit nicer than putting all your coils of cable inside the DC isolator. There's extra slack there should we ever need to pull anything back in. And then string 2 will be the same. Electricity is dangerous, but the first thing is to design out the problem. So have it clearly visible, have it identified with labelling, and have it mechanically protected as well.
The final stage, the solar panel is connected into the inverter, making sure that that's testing out and working correctly. And then we do the same thing with the AC, so making sure the AC power is coming into the inverter and that's all testing out okay. So when it comes to doing our DC tests, we use the C-Word PV200. And what this does, it goes through ampage and also puts a voltage through it. So we're testing the mega ohms through that. And then when it comes to doing our AC, we're testing the voltage, we're doing insulation resistance tests, we're testing the ZE, the ZS and things like that. And then once the AC and DC are testing out okay, you can switch on the equipment.